Hey there. So, you've seen them, right? These absolutely incredible images all over the internet. Photorealistic portraits, impossible landscapes, things that look like they were pulled straight from a dream. And they're all made by AI, from just a handful of words. The big question is, how?
Right. How does a computer actually turn a simple phrase like an astronaut riding a horse into a detailed, coherent picture? It feels like straight up magic, but the secret behind it is actually this incredibly elegant idea. The key to this whole revolution is a concept called a diffusion model. And trust me, once you get the hang of it, you'll see that this magic is really just a super clever step-by-step process of creation from chaos. When you boil it all down, the entire process really comes down to one core skill, the art of denoising. Now that might sound technical, but the basic idea is something we can all totally get our heads around. Okay, so check this out. To teach an AI how to create, you first have to teach it how to destroy. It's called the forward process. You show the AI a perfectly clean image, and then you add a tiny bit of random noise, like TV static. Then you do it again and again and again, hundreds of times, until the original image is completely gone, leaving nothing but a mess of pure static. The whole time, the AI is watching, and it's learning exactly how a picture dissolves into noise.
And this is where the magic happens. Now you give the AI a screen full of completely random static, and you ask it to do the exact opposite. Predict what a tiny bit of that noise is, and remove it. It repeats the step over and over, and with each little bit of noise it removes, a coherent image slowly starts to emerge from the chaos. It's kind of like watching a sculptor carve a masterpiece out of a block of marble. So that's the big takeaway, right? A diffusion model is basically a master denoiser. It gets so good at subtracting noise that it can start with pure noise and just subtract its way, step by step, to a brand new, totally original image. Now, that core idea is brilliant, but turning it from a cool theory into the crazy powerful tools we have today, well, that meant solving three really big problems. Let's break them down. First up, speed, or, well, the lack of it. The original method was just painfully slow. To get one single image, you'd need more than 1,000 of those little denoising steps. It could take minutes, which is fascinating for research, but not super useful for, the rest of us. The game changer here was a breakthrough in how the model removes the noise. Instead of 1,000 tiny, timid steps, researchers developed smarter ways to sample, like a method called DDIM. This let the AI take bigger, more confident steps, getting almost the same quality in just 20 to 50 steps. This was a massive speed up that made everything suddenly practical. Okay, problem 2, control. It's cool that the AI can pull an image out of static, but how do you tell it what to create? How do we make sure we get our astronaut on a horse and not, a dolphin in a library? The solution for this is a super clever technique called classifier-free guidance, or CFG. The best way to think about it is like a guidance dial. You turn the dial up, and you're telling the AI, hey, stick really close to my text prompt, no funny business. Turn it down, and you're giving it more creative freedom to play around. It's that dial that lets you find the perfect balance. And that brings us to the third and final massive hurdle: raw, brute force computing power. Doing all those calculations on a huge, high-resolution image, pixel by pixel, it's just incredibly demanding. It took a ridiculous amount of memory and processing power that most people just don't have lying around. And the solution they came up with was just genius. They basically said, okay, instead of working on the giant pixel-heavy image itself, what if we worked on a much, much smaller, compressed version, like a little data blueprint of the image? And this is the secret sauce behind huge models like Stable Diffusion. It's called latent diffusion. Here's how it works. First, a part called an encoder takes a high-res image and squishes it down into a tiny, compressed latent space. Then, the entire denoising process we just talked about, it happens on this tiny, efficient little blueprint. It's way, way faster. And then finally, a decoder takes that finished blueprint and blows it back up into the full-size, high-res image. This one trick dramatically slashed the cost of computing, making it possible to run these models on regular consumer gear. So you take those three breakthroughs, making it faster, making it controllable, and making it efficient, and you get the absolute explosion of creativity we're seeing right now. So let's do a quick flyby of the major players out there today. Each of the big models kind of has its own personality, right? Stable Diffusion is famous for being open source and built on that super efficient latent diffusion method.
DALL-E 2 was a pioneer in using another AI called Clip to really understand the text prompts. Google's Imagen basically proved that if you have a massive language model, you'll get way better images. And then you've got Midjourney, which has carved out this amazing niche for creating these beautiful, artistic, and often surreal images. And what's really cool is that this tech isn't just for making new images from scratch. The same logic lets you do amazing editing tricks, like in-painting, where you can erase something from a photo and have the AI fill in the blank perfectly, or out-painting, where you can literally expand a picture beyond its original borders and have the AI imagine what was just out of frame. It's wild. This whole field is moving at an absolutely breakneck pace. So, with everything we've seen so far, you have to ask, what could possibly be next? Well, the next big obsession, the next major frontier, is all about speed. The goal is to shrink that whole generation process from dozens of steps down to just a handful, or maybe even just one. Yup, you heard that right, one-step generation. New models like consistency models and rectified flow are shooting for exactly that, creating a high-quality image in a single shot. Imagine that. It would make creating with AI a completely real-time interactive experience. But it's not just about getting faster. The very engine inside these models, the core architecture that's doing all the heavy lifting of denoising, that's getting a massive upgrade too. For years, a design called the U-Net was the standard. But now, it's starting to be replaced by something called diffusion transformers. This is the same powerful, scalable tech that powers huge language models, and it's letting these image models scale up to billions and billions of parameters, capturing way more detail and nuance than ever before. And finally, this core idea of diffusion is just bursting out of the 2D world. We're not just talking about flat images anymore. The same exact principle of starting with noise and cleaning it up is now being used to generate video, to create 3D models, and even to synthesize audio and music, all from a simple text prompt. You know, it all started with this strange idea of destroying an image to learn how to create a new one. And now, that same idea is on the verge of generating entire worlds, videos, and sounds from just a thought. It really makes you stop and wonder, if this is what AI can do today, what are we all going to be creating with it tomorrow?